Welcome back to the next episode of 100 Days of Code. I realized what muted my mic halfway through the episode last time. It's because I was doing a fancy way of running the program, and F10 is a hotkey that mutes my mic. So I'm impressed at my own ignorance, but nonetheless, here's what we're going to do for this episode. This is our agenda items. We're going to detect white text and do the same filtering that we're doing here. We're just going to do it with white text instead of just black text. And then after we do that, we'll want to compare both white and black text and just sort of see what's the area going on for that stuff. Technically, this is going to be just white text, because at the end, after we post-process everything, hopefully this will run. Hello? Okay. So, or technically it's all going to be black text, because that's what we turn it into at the end. And we're just going to see if we can get the area of this text, see if one thing has more text area than the other, because we're only trying to text one color of text. So we're just going to look for the area on both. And that way we can sort of hack our way into finding out, is this image white or black text? So that's what we're going to be doing. So I'm just going to copy this stuff because really we already have the logic in here. So I'm going to change these values. So we're going to switch up the equalities here. I think we're going to want image to be less than that. Less than or equal to, and then greater than, say less than or equal to, let's go with 235 all around, and we can adjust accordingly. Alright, and then for this we're going to say image is less than, I want to say 235 for everything. And I got to remove that equal sign. So we want all the exact values less than that. Alright, so I think this should work, hopefully. I'm just going to comment this out because we are setting things equal. Here, we're going to have to create like two different images, basically one for white, one for black text. So let's just pick an image with white text. I sort of like this one because we were having problems getting the contrast here. But if you look at it, it's perfect for what we're doing because this is pure white. This isn't quite white, so we'll see. And I think I actually, let's run this first and then I'm going to see how it goes. And then move these images out while we're working on this. Let's run this guy. Well, that's not what we wanted. Perfect. This is really weird. Okay, so I am getting the correct values. Where I'm switching all the rest of the pixels is messing it up big time. But I sort of want to compare the original image. Now the funny thing is we actually have sort of this red. So this is one of the images that we could have problems with. And again, we don't have to stick to this red either. I just don't really know how we can sort of save these pixels in a way that is obscure from whatever is in this image, no matter what color. Possibly setting them to either all text completely pure white. Actually, that sort of makes sense because that way we would be safe from anything else. Because nothing should really be pure white for the most part. So that's sort of what we're banking on. And that would remove the need for this third line of code. So I'm just going to increase this wait time just so we can compare images. See what's picking up. So this stuff is actually getting picked up. So what if we increased this to 240? Alright, so there's less noise in here. I just want to keep increasing this threshold. So yeah, we're getting a little bit of choppiness coming up here. So I think 240 is probably going to be a good place for us to go. And obviously we can just adjust this value as needed. I like this because catching a little bit of the umbrella, but you can see besides that, not getting much else. So I'm just going to try turning this stuff in pure white. Let's just look at that. Oh, that's black. I'm smart. And that is what we're doing. So we are turning the text into pure black. That's what I meant, so that works. It's going to work perfectly fine for our needs. All right, so now that we've got that working, we don't need this line. Let's run this. All right, so compared to, yeah, we're going to need a logical and. We're going to need to do the same sort of test here. And we're just going to say where I am is greater than or equal to 111. That should get everything besides our text that we just set, and is less than or equal to 255. Which technically could be 240 as well. Actually, it's 100% of the time. It doesn't really matter. It's not going to change the outcome. And then instead of equals, we can just say less than. Let's see if that helps. Boom. So again, getting a little bit of our noise, and it's actually strange that these aren't getting exactly mapped. Those must be pure white, I guess. But there we go, getting the same effect. So now we're going to have to look at creating two separate images here. Let's see. I'm a little bit worried here because I don't know with Python if when I assign this, if I can say I am white equals I am original, if it's going to do a soft copy or a hard copy. Obviously we want a hard copy because we don't want to affect this original image for our thing. So I'm going to change this all to I am white. We want to change that, but then we want to target the original. It doesn't matter. Actually, I'm just going to go with I am white. And so what I want to do here, test out if it's doing shallow or deep copy. I'll do underscore original. And just see. It should be the original image. I'm using I am somewhere. Yeah, there we are. Alright, this is our problem. I need to look up how to do a hard copy. I'm also going to move these guys to the next line. Formatting looks a little wonky, but now we can align. Alright, now we're reformatted to PEP8 standards. And I want to look up how to do a hard copy. Alright, so there's just a built-in copy function. Import copy. From copy, import deep copy. Okay. And deep copy. Okay, so now we're using I am white on everything. Should be the original image. Perfect. So that's what I was worried about. Learned how to do that. And then this is going to be our I am black. And then I actually want to expand his variable names a little bit. So how do I say black text? And then, yeah, that's what we want to do. We want to turn a deep copy of the original image for both things. Now I can even go ahead and do this. And we just have to change a lot of variable names. Cool, cool, cool. So, gather black text from image. And we'll say here, gather white text from image. So now we're getting both. So let's print out 3 different things. Image, and we'll say origin. I sort of like that more than original. And then we'll say white text. Image, black text, black text. white text, and we're only going to get the name results back for the white text. That's fine. I just sort of want to visually make sure. Alright, so black text is freaking out now. Oh, but that makes sense because the text is white and we're only picking up pure black basically. It's not very helpful. What's interesting it is almost picking up the contours of the letters. So like right here, this is 671 pixel, which is pretty crazy. So there are actually pure black places on even white text, but I think this is working out as expected. So if we were to go back and move these guys back in, just for reference, these texts have black text. So I'm going to reduce that back to 5 seconds. Let's look at this. Boom. So that's actually pretty cool that our white is picking up some stuff, but again, have this working out pretty well. And so there's a lot more noise in that image, and it is not too bad that the white is getting that much. It's pretty cool. All right, so now we have both, and so now we're going to want to get 2 strings. So we're going to say white text result, and then black text result. The worry that I'm sort of feeling here is that we might get some weird results. Let's just print out result no matter what. Alright, so I'm printing out the black text first and then white text, and then we'll see what's going on. I'm also going to change this 10,000 milliseconds so we have time to see the results. I'm jamming. So tired. Alright, and I never changed black text. I was like very scared for a second there. I was getting the same result. That would have been bad. Perfect. So you can see this one's been reading out pretty well. But obviously it's nonsense in here, but in the black text it works perfectly. So this one's actually empty, which is good. We don't want it picking up random noise as much as possible. That's really good. So in a way, look for amount of dictionary words in a string. I'm hoping that there's a library in Python that will have dictionary values, and so it could give us sort of like a score. I basically want to see if there's a library in Python that will tell us how many dictionary words there are, and hopefully like a little bit of an error rate. That would be really cool too. So that way we can determine, okay, there's possibly text here or here. And we could probably, thing is just going to be the balance, because like we can make this stricter. So it means that we'll get less noise. We'll get less noise for this, but that could also decrease the predictions of the right text color. Alright, so at that point, we have basically gotten the first part down. I sort of want to do a couple of things here. So next steps are like, we want to get the area taken up by words. And then we also want to see, if there's Pietsch settings / configurations. That will improve our accuracy. I'm going to go research the first one. Alright, so there is a built-in function with Pietsch that's image to boxes. And so it returns coordinates. Not exactly sure what all the coordinates mean, because there's 5. And apparently the image to data function also includes some data, so I just want to try this to data. So I'd just be curious to see what is returned with this guy. Apparently the width and the height is included with data, though it's returning a numpy array. Oh, that's absolutely perfect. So we have page num, block num. So I'm not sure what these guys are, but it returns the width and the height of the boxes, which is great because then that means that we can get the total amount of pixel values and then go through that data and add up the area of each word that it's getting. There we go. Okay, so we're only running the boundary boxes on the text. So obviously, I'm not exactly sure what we're drawing and have to wait until we get an image with black text. There we go. So it's actually doing a pretty good job. Actually pretty interesting to see how it's looking at the image as well. I think this is going to be a pretty good test to see how we can improve the accuracy. Alright, I'm adding PSM10 into here, but we're not going to use PSM10. We're going to try something different. So we're going to try out this number 5, assume a single uniform block of vertically aligned text. Just see how that goes. That was 4, right? Same thing. Alright, so I changed some of the settings on here and didn't really have a difference compared to the default, so I'm going to take that off. But honestly, I think we're sort of hitting a wall here because there's only so much you can do without creating a whole data set, labeling the text in it, and that would work pretty well, but that's very time consuming. I really wish that there was a labeled meme data set. This whole project's just got a lot more interesting. So there is a huge data set, 45,000 2016 presidential election memes. We're back in the money. This will be what we can dig into. So that way we can train and say, okay, here's what text looks like, here's what the text actually is, predict what this is. And you'd hope that there would at least be some different types of text in here, like different fonts that could help increase our accuracy. Anyways, that's it for this episode. I'm going to go push this code up, and you can go visit that. I'll have the link down in the description. Thanks for watching, and I'll see you next time.